It's my pleasure to introduce to you your next speaker, Wesley Beary, otherwise known as, I'm sorry, let me say that without rushing, Wesley Beary, otherwise known as Gmus. You may know him from such hits as the Fog Gem, and as well as his contributions to MERB and Data Mapper. And here he's going to talk to you today about API development. So thank you, Wesley.
All right, thank you. All right, so I am going to hopefully instill a little bit of the ideas that I've come to from mostly consuming far too many APIs, so far as I'm concerned, and trying to deal with some of those idiosyncrasies and good things to think about in terms of actually designing your own APIs to make it easier for other people to consume them and to develop on them yourself. So first off, I think this quote is great. It's that common sense is the collection of prejudices acquired by age 18. And I think this really kind of sums up one of the big problems with API design is you're too close to the problem, almost assuredly. And so when it comes time to develop this API for other people to use, it's really easy to make assumptions that people who aren't as familiar with it would not make, which makes it really difficult for them to actually come in and become accustomed to it. So first off, of course, API, which I think you should think about as assumptions, probably incorrect, all right? Like, you need to make sure that you're not putting the cart in front of the horse. Like, there's certain things that are going to make a ton of sense to you and no sense to someone who doesn't know your vocabulary and or the way that your internals just happen to be. Sometimes that's how APIs end up. That's not a good design decision necessarily. So the secret, of course, to creativity is knowing how to hide your sources. I think a great thing to do is to beg from your colleagues about, get their ideas of how these things work. Don't just go off into a corner somewhere and do API design in isolation. It won't be used in isolation by any means, so make sure that you get the input of people who are also close to the problem but have differing opinions from yourself. Borrow. Go out and look at the APIs of open source projects, for instance, that are maybe in a similar field or the same field. See what vocabulary they use. You know, do they use REST? Do they use RPC? Like, try to see what kind of things you should consider based on what other people that are in a similar space are using. And then, of course, steal. You know, if you're doing something competitively and you have a competitor that you're looking at that has an API that you know is good, consider just taking some of those things and using them wholesale or nearly wholesale. Like, if it's working for them, it could work for you. Maybe not, but it could. I mean, you should consider that angle. So we cannot solve our problems with the same thinking that we used when we created them. Again, you just have to be very careful that you don't end up painting yourself into a corner by, you know, implementing an API based on internal stuff that has no meaning to anyone that doesn't happen to be looking at the code base. So try to get peer review as you're working on it. You know, don't, again, work on it in isolation. As you get a version of it out, maybe your version is on the whiteboard, right? V0.1 is on the whiteboard. There's no code behind it at all. Bring a couple guys in and say, here's what I'm thinking. Does this make sense? You know, will you get annoyed that you have to type these 4 things over and over again as you implement against this API? Is that okay? Do we need this level? Come up with some use cases. Don't just say, well, we know we have all of these objects. We need to expose all of these objects in a RESTful API. Let's just expose all of them, right? You should think about what are the customers actually going to do, you know? Maybe you never interact with a particular object except for when it's nested under some other object, right? So maybe you should have it so that you just post to the parent object and have nested attributes in it. And maybe you don't expose the child thing at all because the child thing alone means nothing, right? Who knows? But having use cases can help narrow down that focus. And finally, it's really important to try to have this idea of beginner's mind, of think about if you knew nothing about this and you came to it, what would you do? What would make sense to you? How would you approach it, right? It's very difficult to do, which is why it can really be helpful to build these use cases and have peers come in because they're likely to see angles of what a beginner might see because they're more of a beginner than you are that you might miss. So design is the art of gradually applying constraints until only one solution remains. I think it's really powerful to start with some constraints because that way you don't have as large of a problem space. A smaller problem space is easier to work in. A good example, I think, is when it comes to data formats. You know, it's pretty easy, especially in Rails, to say, well, let's provide JSON and XML and whatever else the person might add as an extension that we have a to_something method for, right? But in many cases, I think it might actually be better to design specifically for JSON, because it is a more constrained thing than XML. There's a lot of crazy stuff you can do with XML attributes and stuff. But if you design for JSON, it's going to be an overall simpler data format that you can still create an XML version of. But overall, you've constrained yourself into a simpler format to begin with, which makes some of those early decisions easier. Similar to that, you should think about what format things actually will come out in. Does JSON make sense? Is XML? Should it be RPC? Depends a lot on your customers, but also your use case. In some cases, some things might be completely non-performant. Maybe you need to use protocol buffers because otherwise it's just not fast enough, which is, of course, protocols. So, concern for man and his fate must always form the chief interest of all technical endeavors. Never forget this in the midst of your diagrams and equations. All right? It can be really easy to just think about the elegance of your solution, or how pretty the code is, or how dry it is, how much you've been able to refactor it down into this little kernel of deliciousness. But what really matters at the end of the day with an API is whether or not people can use it, right? So the first thing you should really think about is it easy, right? And it's not just, is it easy to use, but is it easy to use? Is it easy to maintain? Is it relatively, easy to look at this thing and get a sense of what it does? Do you have to read a lot of documentation, or can you look at it and just kind of know because you've seen APIs like this? You've seen, these objects, these constructs. You kind of get the idea, right? And also just, easy to develop on. It's important that you can make changes over time. Another thing that you should think about while you're working on this is that it's practical, right? Sure, you could have like a SHA 1 million hash that you have to calculate for every request, but it's completely impractical, right? And most solutions really don't need it. It would be inappropriate to have a huge, difficult-to-use security protocol for, say, a Twitter client, right? Because Twitter is not something that needs a huge, huge amount of security. So you're creating a huge burden for your users if they have to do some crazy signing mechanism that they've never heard of before in order to post a tweet, right? For that, you can probably use a much simpler method of signing or authentication. So intellectuals solve problems, geniuses prevent them. So the first thing is you should try to make this thing tamper-proof, right? It shouldn't just be that it's easy to use. It should actually go a step further and try to make it hard to misuse, right? If you do something that is invalid or incorrect, try to provide good errors. Or even better, try to not even provide that action at all if it's one that's likely to be misused or misunderstood, right? Maybe you can roll that action up into just something that happens when you take some other action, because those two actions always happen in sequence or something, right? There are usually ways that you can try to make this better and cleaner. And also, commonly talked about in the Ruby community, the principle of least astonishment, right? You should try to make, whenever possible, it shouldn't be, whoa, that's surprising. Why is this resource plural and all of the other ones are singular, right? The more times you do that, the less the person is actually going to have trust in the way that the system is architected and feel comfortable with it. Every time you're surprised, whoa, wait a second, that broke my expectations, then you start to question all of your other expectations of the thing, right? You might have been comfortable with it at first, but you can only sort of say, whoa, what's going on here so many times before you're pretty skeptical of the whole thing. So that's very important to be careful about. And finally, it's really great to have sensible defaults, right? This is some place where you can actually take this, the system way better than a beginner thing, and turn it into a strength rather than a weakness, right? Coming in, they may not know what the best image to choose for an AMI on EC2 is, right? Difficult choice. So maybe come up with a default for them that's good enough for most people when they're getting started, because that's one less choice they have to make before they get to the point of actually using your thing. Once they're actually using it and become more sophisticated, then sure, they can come back and change that. You shouldn't remove choice, but you should provide good defaults. All right, so any intelligent fool can make things bigger and more complex, but it takes a touch of genius and a lot of courage to move in the opposite direction. So in terms of this, it's really important, again, to strive for consistency, because anytime you break that consistency, you're breaking expectations, you're breaking your sort of like bond of trust with your end user. You should also strive for modularity. As much as possible, reuse the same concepts or even the same code across different parts of the API so that in the end, the expectations do not get broken, right? If you reuse stuff, then of course it's going to work the same. You don't have to worry about that as much. And provide good documentation so that when people do run into those edge cases that maybe you didn't foresee that this could be confusing for someone, they have a place to go back and look and get a sense of what's going on there. All right, so you should make everything as simple as possible, but not simpler. The first thing to do there is definitely to focus on abstractions, right? It's very easy to just provide something that just provides a raw look into all of the possible resources that might be inside of your app. That is frequently way inappropriate, right? Like if I want to, for instance, boot up a server in the cloud, I probably usually don't care about exactly what kind of disk controller it has and like exactly what kind of disk and how much RAM and so on and so forth. Like there are some of those details I care about, but I don't really want to have to set 50 options and configure 50 different resources before I have a running machine. I pretty much just want a running machine, right? There are places where abstraction can really help out your users by taking that extra knowledge you have and condensing things down so that they don't have to deal with the nitty-gritty as much. A great place to do this from is generalizations. If you see that people always are doing those same 4 operations together, maybe that should be one operation that does those 4 things behind the scenes because, yeah, maybe it makes it a little bit more complex for you, but that just removed 3 steps from every single user's application. You may be like undrying your application, but it's for the sake of drying every single user's application, which is, I think, very worthwhile. And from that, another thing, kind of the same thing in a different way, is extractions, right? If you find that you are also doing something in a lot of places the same way, you should try to extract that out into a shared location in order to reduce your own duplication. All right. Any man who can drive safely while kissing a pretty girl is simply not giving the kiss the attention it deserves. So as you work through this thing, right, the first thing, if you're doubtful about whether or not you should include something, just don't include it, right? One of the big dangers with APIs is frequently once you've released it, it's quite difficult to change it because as soon as you start getting users and adoption, if you change anything, you might break something for Lord only knows how many users, right? Hopefully a lot. You want a lot of people to use your API. So it's much better to add things in later that you realize were missing than it is to add a bunch of stuff in that you think that someone might need, because inevitably, even if people don't actually need it, someone will find a reason to believe that they need it, and then you'll have to support it forever, which is no fun, generally. So along those same lines, you should try to do one thing really well, right? You should try to focus the API as much as possible and separate concerns, right? So if you end up in a position where your API is doing, is nested 6 levels deep and is doing 2 or 3 drastically different things, you might have 2 or 3 actual different APIs in there that you ought to tease out into different places, remove some of that nesting, and just, keep the car-related stuff here and the boat-related stuff there, right? Maybe you don't need one general thing that does cars and boats because there's too much that's different between the two. All right. No amount of experimentation can ever prove me right. A single experiment can prove me wrong. As you're working on this, I think it's really important to start simply and quickly. I think a great place to do this is on a whiteboard, especially provides an easy way for you to get feedback from others. And I also find in a lot of cases, as you're working through an example, you quickly realize if there's redundancy or something is like way too long or nested too deep, because you get really tired of writing out that really long URL over and over again, right? You can't just copy and paste it, you can't cheat. So it really helps you to move along towards more like what a new user experience might be like. I think it's really important also, whenever possible, try to actually be using your API somehow. Don't just create an API that you kind of like push over the fence and let your users deal with it. If you're consuming it, you're much more likely to see those rough spots that they see. See that one action takes 10 seconds to return, which is just crazy, right? Like, you may never realize that if you're not consuming your own API until you hear about it from your users. And it's better, to preempt that. Find the problems and fix them before they really become problems and that the users actually see them. And finally, fail fast, right? As much as possible, if you can whiteboard it and realize that something isn't going to work, you can start working through the examples and see, oh yeah, this works, this works, this works. Oh wait, in the delete case, that's just not going to play out. I forgot about that, right? How is that going to fit back into the grand scheme of things, right? The faster you can fail by testing it yourself, whether it's on the whiteboard or in a real prototyped API or whatever else, the quicker you can see where some of these like obvious broken things are, right? You'll never catch all the broken things, but the big ones you can catch before it's too late. So if you can't explain it simply, you don't understand it well enough, right? You should early on assert exactly what it is that you're trying to do. You should assert how you believe that the API should work. In the same way that you have use cases, it's valuable, I think, to have a strong assertion of like, these are the resources that are provided, these are the actions that are available to users, this is what I expect should be there, right? Because it will constrain you. It will provide you that path to follow as you actually work through your implementation. The second is to make sure that you communicate that, right? Communicate to your users what your beliefs are about what the API should do and how it should do it, right? Because having just a document that lists all your URLs is one thing, but having a document that says, oh, so you want to boot a server? Here are the 4 steps to boot a server, right? Like being able to really see directly what it is, how you undertake a particular action. Turning those use cases into tutorials can be a really good thing to educate them on use cases. And along the same lines, I think mentorship can be very valuable, right? Pick a few of your sort of superstar users, your power users, bring them in as early as possible and get them on this thing, right? See what issues they have and help them through them, because you will learn a lot in that process and they will probably love it, right? They're already your power users, so they're probably going to be super excited about it. Excuse me. So it's not that I'm so smart, it's just that I stay with problems longer, all right? So at this point, I'd like to open it up for questions, see if there are people that have any exceptions to some of these ideas, because who knows, maybe you have some particular use case where this doesn't make any sense at all, or if you just doubt me a lot, that's also quite possible. This is my information. I think it was kind of covered pretty well by Josh, and there are some more examples and notes at this gist. I didn't want to get too far into the nitty-gritty of specifics because that's not very fun sometimes, but this goes through a couple examples of where I was trying to kind of do the whiteboard thing to see what a CLI for Fog might look like, and what an API, like a web API for Fog might look like, and how I ran into some problems in the revisions that I went through to do that. So hopefully, anyway, that might be an interesting insight into a process for me actually doing this. And there's also some notes to a couple sources that I used in putting this all together. So at that point, any questions would be awesome.
Thanks for the talk. I was wondering if you could talk about versioning APIs and what some good practices are around that.
Sure. So the question was about versioning APIs. It's difficult because I think in a lot of cases, the right thing to do for users is not an easy thing to do for developers, which is to say, ideally, the old versions don't stop working, but they just maybe don't get new features, right? And new versions add new features, but you probably still need to backport any major bug fixes. I don't know. That's where it starts to get tricky. I don't know. I would almost lean towards saying, once you've released a version, maybe it's best to just not touch that version at all, right? If there's a bug in it or something, just do a new release. I think that in some cases, we're way too reticent to not have a new version of the API unless it's a very significant, drastic change, right? But if we're developing a gem, we don't think that we have to go from V2 to V3 directly. Maybe we need minor versioning around APIs, so we can say, this is V1.1. It's 1.0, but it fixes one particular bug. But you should know that that might also introduce other behavior change because of that bug fix.
Yeah, and specifically from a Rails point of view, do you normally just namespace it all under something and release new versions with a new namespace, or how do you do that?
I don't, so I have no idea. Basically my job for the last year or so has been working full-time on Fog, which is a Ruby library for cloud abstraction stuff. So I haven't touched Rails in quite a while. So unfortunately, I don't exactly know how specifically in the nitty-gritty of it I would implement the versioning side of it. Namespacing would probably make sense. Again, that's where it kind of starts to get really hairy, right? Actually having in your code base 50 different versions kind of at the same time because they all need to be available is painful, right? But it's probably a better user experience if people can know, oh, well, if I want this bug fix, I step from 1.0 to 1.1, but then I know that there might be something that's different that I should keep an eye out for, other behavior changes. I don't know. It may be some problem that we haven't solved yet because that's not really how most people are doing this. But I would prefer to see, I guess the main point is I would prefer to see those old versions continue to live. I've seen some places where they kind of like pretty quickly like retire 2 versions or older and it just goes away. And it can become very difficult sometimes to just like keep up with the chase, right? Like if I've written an application that works against your V1 API and it works, I shouldn't have that break and have to change stuff later, right? It should just continue to work even if there are bugs or hairy spots or whatever, right? Because if my app doesn't care about the bugs or hairy spots, then you should just let me be happy, right?
Can you repeat the question?
What about security patches in the app that shouldn't care about the bugs? Like the version you have to upgrade.
That's a good question. One that I don't know that I necessarily have the best answer for. I think that security stuff might be an exception where backporting it into a version is probably worthwhile. I mean, there's always the danger, of course, that in backporting it you introduce some other behavior changes, but I think that's probably worth it. For bugs in general, maybe not worth it. Like maybe better to do something like minor versioning or something for bugs, but security is worth probably forcing it on people, basically. And if it introduces bugs, well, it's better for them to have bugs than to have a big security hole. Yeah, and regression testing should hopefully cover a lot of that.
Great talk. Thank you very much. I have 2 questions. The first one is, what do you think about API discoverability? And then the second question would be, Fog is an example of an API that wraps around other APIs. What do you think about the difficulties in sort of reaching a least common denominator of functionality when there are back-end systems that provide specialized abilities that others do not?
Sure. So my mind started wandering into the second question. The first question was?
Discoverability.
Discoverability. I think discoverability is good and valuable, but not a panacea. I don't think it should be the only thing. I think there should be ways to figure out what the API is without having to interrogate it. And there are some things where it seems like you kind of have to interrogate it to get the API. Like I think Delta Cloud's kind of that way. I didn't really like that. Like I don't want to make an API call to find out what API I'm dealing with. But it is very valuable if the API is structured in such a way that it is easy for me to explore and discover it. Not exactly discoverability, not explicit discoverability, but implicit discoverability, I guess, is where my favor lies. The other question was more about trying to reach lowest common denominators with APIs. The example being, Fog trying to provide, say, rack space servers and EC2, even though they have some pretty drastically different feature sets. I think that's a place where looking at use cases is very important. Kind of like I said, I think that for most users that want to do something with cloud resources, at least as a user that's getting started, they want reasonable defaults, and these services tend to have not provided them. So I thought that, I guess in some ways, I felt like there was space there to step in and say, new user experience could be way better for using servers in the cloud, right? I don't want to have to worry about whether or not there's an EBS volume attached or not, or whether I'm using, instance or volume-backed storage or whatever else. Like, I just want to boot up a server that I can SSH into and do some stuff, because that's at the level that's where you come into that, right? Like, you don't come in with this complete knowledge of these intricacies. So I think that in designing an API that wrapped other APIs, I still used a lot of these same ideas. I just had a lot more varied resources and constructs in the background that I had to deal with, which certainly makes making the abstractions more difficult, because you have to sort of try to unify across them instead of just saying, how do I present, cars versus how do I present boats? You have to realize that somebody else also has 5 different models that represent different kinds of airplanes, and you need to accommodate that as well. And I don't know. And most of the time, one of the biggest things that I think that I could say is that you should try to find at least 3 examples of the thing that you're trying to deal with, and then from those 3, try to come to some understanding of what's actually common. Like, trying to do it from one, you'll definitely miss things. Trying to do it from 2, you'll almost assuredly miss things. But if you get to the point of 3 or more, you're usually pretty safe. And that's a rule that I've heard other people state too for things in general. But that's how I would approach it. That's how I've approached it historically. Most of the services that only have 1 or 2 don't have that nice abstraction layer because I don't feel like I know enough about what that problem space looks like and what the new user would want to be able to do it reasonably.
I have a question for you myself.
Yeah.
Did you see the recent technical blogging from Netflix about their API changes?
I don't believe I did, no.
Okay. I won't go into it too much then. They took an approach where instead of having versioning in their API, they split it out into multiple endpoints to support different devices.
Interesting.
And I found it really interesting. They said their API had different constraints for different types of devices. Your iPhone, you only get a couple different movies they want to talk about, whereas on your TV, you might get 20. So,
yeah, I think it's a use case that is unlikely to occur for most API developers most of the time, that you would be that drastically different between your iPhone and TV or something like that. But I think that's a great example of dividing up your concerns, right? Like, obviously the concerns for one device are drastically different from another, so why should you try to force them all in and do some check some header to see what device you happen to be in and then branch in the code or something? Why not just have a separate endpoint? I think that's a really great idea.
Okay. Anyone else questions? Okay, cool. Well, thank you very much.
Thank you.